Hey, hi guys, welcome to my channel. So in today's video, we'll be starting off with visualization. Since we have finished the Python advanced playlist, and I hope you guys have gone to the previous playlist before in Python. We have we have created detailed, chapters where you can go to easily. So today we'll start off with visualization. And when you talk about visualization, one of the most important aspects which you need to understand is that whenever we do visualization, when we visualize data, it always becomes very easy to interpret data, to draw out insights from data or pick out hidden patterns from data. And that is why visualization is very, very important, guys. So two of the most important modules which are available in Python for visualization is matplotlib and seaborn. There are other modules as well, but these are two of the mostly used modules which we have in Python. So let's import the libraries first. So these are my libraries. NumPy is NP, pandas as PD, seaborn as SNS, matplotlib, .pyplot as PLT. So when we talk about matplotlib, the entire library, inside it, we have a function which is called as, or module which is called as pyplot, and that is where we call all the functions from. Why do we need two libraries in the first place? Typically, when you look at these two modules from my experience, what I've gathered is seaborn and matplotlib, both of them can do plottings of any type. Okay, they can do build graphs. The same graphs which are available in seaborn are also available in matplotlib. Yes, the syntax will be a bit different, but matplotlib is also used for aesthetics. What does aesthetics means? Suppose you have a graph and I want to increase the figure size, I want to reduce the figure size, I want to plot multiple graphs at a time using a loop, or if I want to plot graphs in multiple grids, I want to increase the font size, I want to include a legend in the graph. Typically matplotlib has that advantage. But when it comes to seaborn, with seaborn, my syntaxes are a bit easier to remember or easier to understand. So in the market or in the corporate, we typically combine both of them. We use both of them in conjunction one another. That is the beauty of it. So, and that is exactly what I'll do today, guys. Instead of showing you different capabilities, what is more important is how do I apply? I think it boils down to that at the end of the day. Okay, so let's start. Let's pick up a data set quickly and start with the plotting the graphs. So let's read the data set first. Okay, this is a data set which is called as empty cars. We'll start off with relatively simpler data sets and we'll build on that. Okay, we'll have a few more lectures on visualization. We'll do comprehensive case studies and we'll try to see how we try to analyze a problem statement using visualization. Okay, so once we have this, now what do we notice here? More than the column names, if I want to do visualization, what is more important to me as an analyst or a data scientist or a person who is analyzing the data from any background is what kind of data I'm handling in my data frame. Each of these columns seems to have varied kind of data, right? Because the column model has a string or object type, which means that's a categorical data. Based on type of data, my graphs which I'll choose will vary. So identifying the type of data is very important, guys. Now, typically when you do df.dtypes here, we see float, object, and integer, right? But when it boils down to plotting graphs, when it comes to plotting graphs, identifying the data is very important. Now, Python will tell me that MPG is float. Why? Because it's decimal points are there. By layman's term, by the rule of the thumb, we typically consider, okay, if it is decimal, there's a chance that the data is continuous. If it's discrete, chances are that data is discontinuous, or if it is, integers. So if you see here, gears, AM, VS, they seem to be discrete. There are no decimal points here. It seems as if gear 4 is a category which is representing all those models which have gear 4. Carb 2 again seems to be a column which has values, which has different labels or categories, as if telling us, okay, that there are some models which belong to this category which has carb as 2 or 4, whatever it is. So these are my discrete data. This is also categorical, and this is, of course, it's discrete by nature, right? Because they seem to categorize the data. Whereas the Data points which are, which are decimal points typically tend to be continuous in data. That is what we assume when we choose a graph to plot a particular kind of column. So let's say let's pick up the float columns first. How will I do that? I'll automate it. I'll not hard code it. This is what we'll have to do. And I want the column names. So I'll simply do this. If you have not understood this point, I request you guys to go back and revisit my previous videos. We have done this before and we have done it in great detail. Okay, so once we have this, what we can choose to do is let me plot MPG. Now, MPG to me maybe seems to be continuous because it has a float type of data. So for float type data, typically we'll use distribution plots. Okay, so there are some kind of analysis which you typically do in any case study. One is called as univariate analysis and one is bivariate, and there are multivariates as well. We'll go to that. We'll go to that definitely, but not that much in detail today because the topic is visualization. When we start off with the statistics and the EDA playlist, we'll definitely cover all these in detail. So for univariate, when it comes to univariate, it means that I'm analyzing one column at a time. I'm trying to figure out MPG or DISP or whatever it is, one at a time. I'm not going to compare both of them with each other. No, I'm going to compare I just plot each of them individually. So let's pick up MPG first. Now, if it is continuous, for continuous data, we can do distribution plot. We can do box plot. But if I talk about discrete or categorical, whatever you call it, I'll use count plot. Let's pick up MPG. So if I want to plot distribution plot, of course, you can plot it using matplotlib also, but I'm going to use Seaborn because easier to remember, easier functions are available. It's handy. As simple as that. One single line of code, hardly much words are there, right? And I got a distribution plot. This is a histogram. Now, I have 5 columns here, which are continuous, which has float type basically. And I do not want to keep on, doing it one at a time, right? I have to put again sns.displot. Again, I'll go here and again I'll write, say, qt or whatever it is, right? And I can't keep on doing it. If the number of columns is too big, I won't be able to keep on doing it. So we'll use a loop for that later on. That is where matplotlib will come in because we'll try to arrange all these graphs in a loop with a grid, right? Let's check it out. So what I'll do here first is I'll go back and I'll name these list as continuous calls. Okay. I want you guys to show the process of automation with the flow so that, we don't have to go back, revisit these codes and understand again. We'll do it on the fly. So if I do in cont calls, whenever you want to loop over any data structure, list is the easiest way to do it. I can simply sns.displot of df of I. So if I do this, you can see here what has happened here. All the graphs seems to have been superimposed on one another. And hence, you can see this, it has to take one particular scale and some of the graphs are not even visible. Because for some columns, the range will be high. For some columns, the range will be low. We'd not want it to be like this. We want individual graphs plotted in a grid, right? That is where matplotlib comes in. We have a function which is called as subplot, okay? So if I do plt dot, so first I have to do plt dot subplot. Now suppose I have, how many columns do I have here? I have got, so let me just quickly do this. Length of, okay, length of font underscore calls. We have 5 columns. Okay, great. So what you can do, plt dot subplot. I can do, say I need 3 columns, 2 rows, 3 columns, 2 rows and 3 columns. So I have to put it here. Before we do the plot, I have to initiate. This is the subplot I want. And here I can simply do count because The way subplot works is that it will first initiate the grid. It will first initiate the grid, and then it will ask you how many rows and columns do you want for me to give the plots. It's not necessary to fill all the grids. If now suppose we have five different columns, I can simply choose a grid of 3 columns by 2. So these 3 spaces will be filled and these 2 spaces will be filled. This will be kept as empty. We don't need to bother about it. But since I'm plotting in a loop, I want to specify that this particular column in I will be plotted in count 1, which is the first grid. The grids are named as 1, 2, 3, 4, 5. The index starts from 1. Please don't forget that. For a second loop again, it will plot in the second number grid. So here I have to use a iterator, or what you call as an incrementer, right? Count equal to count plus 1. So let's see if this works. You can see here, now I have separate graphs with me, right? Now all we require is to set the figure size, because figure size looks small. So we have something which is called as plt.rc params of figure.fig size. Please guys, not worry about syntaxes. The syntaxes we can easily get it from Google. Okay, but what is more important is for you to understand that such functionalities are available in Python, that you can change it. That is more than enough for you to know. At least remember the function name. Syntax you can get it from Google, no problem. Because I've been coding for so many years and taught me so many people that you tend to remember it. So since we have say 2 rows here, let me just say set of size of 5 for 2 rows, which is the height, and the x let me take it conventional, say 15 cross 10. I can make this as 10 cross 10. So you can see the graph has increased in the height, right? The x is still skewed, so I can just increase it to 20. So this represents the x, the width, and this represents the height, total height. So you can now see, you can easily look into it, right? And you can get a first-hand analysis of all the graphs at once, rather than you doing it repeatedly. And you can create a function out of it. I'll show you as well. We can automate the process of selecting the grid size also. Automate as much as possible using Python. Okay, now let's try to understand the discrete columns. Okay, so there's one discrete column which was object or categorical columns, what you can call it as. So let's say now I have the object columns is equal to, let's say df.dtypes of df.dtypes, equal to object. So I have only one column, which is model, right? So for univariate analysis, when it comes to categorical columns, what you have to do, we have to use sns.countplot. Same syntax, df of model. So you can see here that there are so many number of model of cars, right? df, if I want to find out the unique values of the labels of models, what will I do? df of model dot value underscore counts. If I do, you can see here almost all the we have around how much? So how many unique models do I have here? Length of df of model dot unique. There are 32 different model cars, right? Cars of model. And all of them seem to have the same count, which is 1, which means that each one of them is basically repeating 1 time. So if there are 32 models, what is the shape? And if all of them is repeating only once, what is the shape of my data frame? It will be 32. Now, because of this, now you can see here, because it's vertical, you can see that your model car, the car names are overlapping one another because of the length of the string. I can simply orient it to a horizontal figure. So now how do I do it? How do I make it horizontal? Let's see. So if I simply include y is equal to, you can see here, it becomes horizontal in nature because the count plot documentation, we have X and Y, right? So if I put Y is equal to that particular column, it will take the Y axis as the label names and it will draw the count in a horizontal fashion. If I put X equal to this, it will become vertical. Very simple way of transposing or orienting the figure in a vertical or a horizontal shape based on your need. Now, next, what are discrete columns we have? We had only one object column. What about discrete columns? df.d types, same way, equal to int 64 dot index dot to. And if I simply do, these are nothing but my discrete columns or in columns. Let's just call as in columns, integer columns. How many of them are there? 6 of them are there, no problem. Now, can I plot all these 6 columns in one single go, just like we did it for the distribution plot? So what I'll do, I'll simply copy paste this entire line of code, bring it here. Instead of this plot, we'll be doing count plot, and this will be int calls, right? Let's see. Got it. So we plotted all the count plot or bar diagrams, whatever you call it, in one single go. Using the same simple piece of code, only what did I change? I changed the code in 2 lines. Changed the distribution plot to count plot and the column names, list names as well. So you can think about it, if I had a function, I could have done both of them using the same function. And I'll show you exactly this in the upcoming videos, guys. Whenever you automate things like this, it becomes easier. The codes become basically reusable. You can reuse it for your other projects as well. You don't have to keep on coding from scratch, guys. And that is why I have developed this particular playlist where people from non-programming background can also take up and understand how you analyze data in their own fields of work. Now, if you see here, if there are some particular columns which we think is that we can orient it in a horizontal fashion, you can do that. Simply have to change it here. Done. Now, looking at this, it seems to me that cylinder, I think CIL, CYL, AM, gear, carb, VS, and then you have this as what do we call it? Let's see, HP. I think HP horsepower, although it's integer, but seems that it could have been continuous. We don't know as of now. But using the bar plot also, it making sense. No problem at all. Correct. So this is how we use different kinds of plot for different kinds of data. So there is one more univariate plot which I wanted to show you guys, and that is for continuous distribution. I mentioned box plot. So if I want to plot box plot now for all these columns, what I'll do, I'll simply go here and I'll do sns.boxplot. Rest everything else, I believe, would be same. Now, what is a box plot here? Box plot is nothing but it shows you the distribution of the data. And we'll come to that later on in statistics. This line which you see is nothing but the median. This is the 25 percentile. This is the 50 percentile. What is 50 percentile? What is 75 percentile? This is your 75 percentile. These indicate outliers in your data set. And box plot is very useful for us to denote outliers. If the box plot is like this, then your distribution probably is something like this. Let's see. See? It's slightly skewed towards the right-hand side. Same goes for this also, DISP. Right. So box plot can help you identify skewness. It can help you identify outliers. It also gives an indication of median and the quantiles. Now, if I want to check, let's say this is a column which is WT. Its median seems to lie between 3.0 and 3.5, right? This line which you see here. Let's see. np.median of df of WT. 3.325, which lies between 3 and 3.5. Let's look at the maximum value, np.max of df of WT. 5. Somewhat less than 5.55. This is 5.4239. So this is how, using the box plot itself, you get to understand so many important functionalities. You can also look into the percentiles. So let's say np.percentile of df of WT, 25. This is the Q1 or the 25th percentile. 2.58. Slightly, this line which you see here, slightly more than 2.5, which is 2.58125. 25th percentile simply means when you arrange a particular column in ascending order of magnitude. Once you do it in ascending order of magnitude, that value below which, less than, where you have 25% of the entire data, that data point is called as my 25th percentile or my Q1 value. 75 percentile will be that value below which or less than where you have 75% of the data will be less than that particular data. So this value is 250. There are 75% of this entire data set is less than my 250 value. And this 250 becomes my Q3 or quantile tree. That's why median is also called as 50 percentile, because median generally segregates an entire observation into equal halves. One is the 50 percentile, 50 percentile. So 50 percentile is that value below or greater than or less than which 50% of the data lies. We'll come to those things, guys, even in much more detail when you try to learn statistics. And that is how you bridge the gap between visualization and statistics. Okay, all these things we'll revisit when you do visualization. We'll try to do hypothesis testing and try to find out interaction between different columns as well. Okay, so univariate analysis is this for today. In the next video, we'll try to explore bivariate analysis. We'll start off with slightly more complex graphs, and we'll also move on to complex case studies where we'll automate the entire process of building graphs with simply using customized function, where we can replicate this function across all projects. Okay, guys, I hope you guys liked today's session. Please like, share, and subscribe, and keep watching my channel for more interesting updates. Thank you.